Let's start with the integral test. Integral test is used when the given function is continuous, positive, and decreasing function. We think about the interval from 1 to infinity. Let's assume that the sequence is defined by the function at n. Then the summation n equals 1 to infinity, an is convergent. If and only if the improper integral with the function f is convergent. If I elaborate what it says, then if integration 1 to infinity f of x dx is convergent, then the series is convergent. Secondly, if the integral f of x dx is convergent or divergent, then summation n equals 1 to infinity, an is divergent. So by doing improper integral, we can decide whether the given series converges or diverges. But what you have to be careful about integral test is by doing improper integration, you can determine whether the given series converges or diverges, but it doesn't determine what the sum of the series is. So in general, summation n equals 1 to infinity, an is not equal to the integration value. If I repeat it again, then when we think about the integral test, what you would think about is integral test determines whether the given series converges or diverges, but it doesn't determine the sum of the series. To apply the integral test, the first thing you have to think about is the given function is continuous positive, and decreasing. If the function doesn't satisfy all three conditions, then you cannot apply the integral test. Let's do some examples. Determine whether the series is convergent or divergent. Let's consider summation n equals 2 to infinity 1 over n times natural log of n. We want to consider the integral test, so we put f of x equals 1 over x times natural log of x. As I said, to apply the integral test, we have to check whether the function is continuous, positive, and decreasing. So we know 1 over those two are continuous function, and there is no 0 if the given value is greater than 2 in this case. So the function f of x is continuous, positive, and decreasing function on half open interval 2 to infinity. So why is this decreasing function? That is because both x and natural log of x are increasing. So when we multiply two increasing function, x times natural log of x, the new function is also increasing. Therefore, 1 over x times natural log of x is decreasing. Always remember that when you apply the integral test, there should be the explanation about the condition to apply the integral test. And so we discussed the continuous and positive and decreasing. Especially this condition should be verified. In this case, these are pretty simple, and so we can just explain. But in other problem, you might have to do differentiation to demonstrate that condition. So what we verified was we can apply the integral test. So we think about integral 2 to infinity 1 over x times natural log of x dx. And then by the definition of the improper integral, that equals limit n goes to infinity to n. Let's write down like 1 over natural log of x times 1 over x dx. So we will end up doing integration. So what we noticed was differentiation of natural log of x is 1 over x. And so probably we can apply the substitution. So u equals natural log of x, then du equals 1 over x dx. And we have to change the lower bound and upper bound according to the u variable u. So if x equals 2, then u equals natural log of 2. And if x equals n, then u equals natural log of n. So we can rewrite that as n goes to infinity, integration natural log of 2 to natural log of n. So 1 over u times u du, right? So that becomes limit n goes to infinity. Integration 1 over u du is natural log of u. And the lower bound is natural log of 2, and upper bound is natural log of n. Just a common integration. So we have limit n goes to infinity, natural log of absolute value of natural log of n. So this is the input minus natural log of 2. So we have to determine whether this diverges or converges. Of course, this has a value. And if we think about this, then natural log function looks like this. Y equals natural log of x looks like this, and it increases forever. So this increases forever, and this is an increasing function. And so when input increases, the output also increases. So the entire thing will go to infinity. And so when we subtract the finite number, that becomes infinity. So we can say that by the integral test, the series diverges. Any question? The second problem is n equals 1 to infinity, n squared over e to the 3n. In this case, obviously there's no 0, and this is continuous function and also positive function. Those are just the pretty immediate. But the problem is whether that is decreasing or nothing. So what I said is f of x is continuous and positive. So both are, of course, positive, and both are continuous, and there is no zero. So this is y equals e to the x, and there's no zero here, and so the fraction will be continuous. To figure out whether that is increasing or decreasing, you have to think about the derivative. This is a derivative of fraction, so the formula goes like g squared in the denominator, f prime times g minus g prime times f. So we will apply the formula. Indeed, this f and this f are different. F prime of x equals the denominator squared, so e to the 3x squared, and this one's derivative, and so x squared derivative is 2x times the denominator, which is e to the 3x, minus derivative of this one uses chain rule, so e to the 3x times derivative of 3x, derivative of 3x, which is 3 times x squared. So that is the derivative, and e to the 3x squared, and then these two are common factor, so e to the 3x open parenthesis 2x minus 3x squared. And indeed we have another common factor, x, so e to the 3x squared e to the 3x times x times 2 minus 3x. So what we notice here is this component and this component are the same, so we can cancel and simplify, and e to the 3x is in the denominator, and the numerator is x times 2 minus 3x, right? And then we have to determine whether the function is decreasing or not. So this one will never be zero, and so we don't have to care about that. So that is never zero, and indeed that is strictly greater than zero. So it doesn't affect anything about the sign of the entire fraction. And for the numerator, we think about the critical point by putting x times 2 minus 3x equals 0. So x equals 0 or 2 minus 3x equals 0. So we move 3x on to the right side, then we have 2 equals 3x, and we divide by 3 on both sides. Then x equals 2/3. So 2 points are the critical points. So what we are thinking about the sign of this fraction, x times 2 minus 3x over e to the 3x. And then this is 0, and this is 2/3. And there are intervals like this. And I said this denominator is always positive, and the question mark is that this region become negative. So to do that, we will just put 10 to here. And then we have 10 times 2 minus 3 times 10 over e to the 3 times 10. And then this is positive and this is positive. Obviously, this part is negative, and so entire thing is negative. And so all we have to know is that part is negative, because the condition of the integral test is the decreasing from 1 to infinity, or just any finite number to infinity. So decreasing, f is decreasing from 1 to infinity. So we can apply the integral test So we think about 1 to infinity, we go back to the original problem, which is x squared over e to the 3x and dx. So then that is limit t goes to infinity, integration 1 to t x squared over e to the 3x dx. So right now, what we want to focus on is integration x squared over e to the 3x dx. We will apply the integration by parts by putting u equals x squared, because x squared will become simpler when we differentiate. And dv equals 1 over e to the 3x dx. So that becomes e to the minus 3x dx. And so the integration of that will be minus e to the minus 3x over 3, right? And if we differentiate this, then du is 2x dx. So we go this way, right? So that becomes minus x squared times e to the minus 3x over 3 plus this one times this one will make 2/3 integration x times e to the minus 3x dx. So I skipped some steps, so you can ask me a question. Of course, so this is minus integration, minus will make plus, and so plus is in the middle, and 2/3, right? And I put that out of the integration. Any question about this? So we realize that we have to integrate one more time by applying the same method using the integration by parts. So we will put x equals u equals x, and we put dv equals e to the minus 3x dx. And then we do the same calculation. So v will be minus e to the minus 3x over 3, and du equals dx. So again, this is minus integration. So the next one is minus x squared times e to the minus 3x over 3 plus, so we are doing integration by part for this part, and so we have to put 2/3 open parenthesis, and this one times this one will make minus x times e to the minus 3x over 3, and then again minus will make plus, and this time there is no 2 here, and so 1/3 plus 1/3 integration e to the minus 3x dx. And then integration one more time, but that's not the big deal. So minus x squared times e to the minus 3x over 3 plus 2/3 minus x times e to the minus 3x over 3 plus 1/3 times e to the minus 3x over minus 3 plus c, right? So what can you do about this? So we have to expand this out. Then we get minus x squared times e to the minus 3x over 3 minus 9 over 2 over 9. 2 over 9 x times e to the minus 3x, and this one times this one will make minus 9. Minus 9 times 3 will make minus 27, and 2 is on the numerator, and e to the minus 3x plus c. So e to the minus 3x is the common factor, so we will take that out, e to the minus 3x, and this one is minus x squared over 3 minus 2 over 9 x minus 2 over 27 plus c. So what we want to do is we want to think about the common denominator. Common denominator is 27, right? And so that equals minus e to the minus 3x minus 27. 3 times 9 will make 27. So 9x squared minus 27. So 9 times 3 will make 27. And so 2 times 3 will make 6x minus 2 over 27 plus c. And this one can be written as 1 over e to the 3x. So when we combine all those, we get that equals what? All of them has minus sign, and so we will pull that out. And denominator is e to the 3x, and then 9x squared plus 6x by plus 2 plus c. So indeed, it's 27 in the denominator. Any questions so far? All right, so what should we do with this? We are doing improper integration, and we end up getting the general formula for this part. And what we have to think about is what happens when t goes to infinity. So we will copy the fraction we obtained, but let's forget this minus part because we just think about convergence or divergence. So we will copy the fraction we got, which was 9t squared plus 60 plus 60 plus 2 over 27 e to the 3t. So we notice that those two numerator and denominator goes to infinity. So limit goes to infinity. We use L'Hopital's rule. So when we differentiate, the numerator will be 18t plus 6, and the denominator is 27 times 3 times e to the 3t. And then we have to reduce this a little bit because this is 3 times 6 and this is 3 times 2, and 3 is 3's are the common factor. 27 e to the 3t, when we reduce and simplify, that becomes 6t plus 2. And then we again realize that this goes to infinity and denominator goes to infinity again. So we apply the L'Hopital's rule again. So if we differentiate, then that is 6 on the numerator and 27 times 3 times e to the 3t. And then the numerator is a fixed number and denominator will increase indefinitely. So that means the entire fraction will go to 0. Let's go back to the starting point of the improper integral. We were considering limit t goes to infinity, 1 to t x squared over e to the 3x dx. And So we obtained the integration t goes to infinity. The disintegration is minus 9x squared plus 6x plus 2 over 27 e to the 3x from 1 to t. So all we have to do is evaluating. So limit t goes to infinity minus 9t squared plus 6t plus 2 over 27 e to the 3t. And then the lower bound, we have to switch it the sign. And then that is 9 times 1 squared plus 6 times 1 plus 2 over 27 times e to the 3 times 1. So we can distribute this limit to the first and second. And then what we know is this part goes to 0. And whatever the value is, this is finite number, right? And so our conclusion is by the integral test, the series converges. Any question? Let's do one more problem and then I am finishing the 11.3. Summation n equals 1 to infinity, 3n plus 2 over 3n plus 1. In this question, of course, we have to show that that is continuous, positive, and decreasing. Especially decreasing is always a problem. So we think about the function 3x plus 2 over 3x plus 1. And then we convert that into 3x plus 1, which is the same as the denominator, plus 1 over 3x plus 1. So we made two parts and we separate that. So 3x plus 1 over 3x plus 1 plus 1 over 3x plus 1. And then the first part will become 1 and the second part is 1 over 3x plus 1. Then what we realize is that f of x is continuous. And continuous because we are thinking about a certain region rather than the entire function is continuous at any point, because it's when x value is negative 1/3, the denominator becomes 0 and that is undefined, and at that point the function is not continuous. That is positive and decreasing. Decreasing is very obvious because 3x plus 1, this part is increasing. So 1 over that increasing part will be decreasing on 1 to infinity. So we can apply the integral test So 1 to infinity, 3x plus 2 over 3x plus 1 dx can be written as 1 to infinity, 1 plus 1 over 3x plus 1 dx. So that can be written as t goes to infinity, integration 1 to t 1 plus 1 over 3x plus 1 dx. And integration itself is pretty easy. So limit t goes to infinity. The first term's integration is obviously x. The next one is natural log, right? Natural log, but 3 is here, and so we have to divide by 1 over 3. Natural log of 3x plus 1, 1 to t. So limit t goes to infinity. So we plug in t and subtract with 1 after plugging 1. So t plus 1 over 3. Natural log of 3t plus 1 minus 1 minus 1/3 natural log of 4. I just evaluated with 1 to here. And then this part is finite, but this will go to infinity. The second one also go to infinity. And so when t increases, the entire thing will go to infinity. So after we apply the integral test, we can conclude that the series diverges by the integral test. So to make a decision about whether the given series summation 3n plus 2 over 3n plus 1 converges or diverges, we apply the integral test. But there is another way to solve the problem, which is a lot easier. In this case, we can use the test for divergence. So test for divergence says if the limit of the term doesn't approach 0, then the series will diverge. So in this case, obviously that equals limit n goes to infinity. Just forget the lower part degree terms in the numerator and denominator. And then that equals 1, right? That is not equal to 0. Therefore, we can say that series diverges, which is a lot easier. But depending on the condition of the problem, you have to use the method which is indicated, and that's what was going on with this problem. So we finished at 11.3 and 11.4 is about the comparison test. So we are learning about the series, and there are many convergence tests for the series. For this part, it is important to, I think, make a note, the separate note with the statement of the theorem. and what kind of tests are available. And you have to remember all the conditions and conclusion clearly to apply it correctly. Okay, so everybody knows that next week, next Monday is the exam, right? Yeah. Hopefully you will do well on next Monday's exam. See you tomorrow. If you don't have question, then you can leave.